So I want to go over some review on what the syntax of predicate logic is. So we're going to start by defining what all of our kind of objects are. So first off, we have two kinds of actual objects. So these are things that correspond to things in the real world. So we will have constants C or like D3, and this would be written like D3. These are things that refer to specific objects in the world. So they might be like Rilo Ashmore referring to me, or like Justin Trudeau referring to the Prime Minister of Canada. We also have these variables, x or y4. So again, we have like x, y4. And these are also like object type variables, but these are, we think of more of like sticky notes. You could stick them on something, and then that thing takes on that meaning of that variable, but you could always like remove them and relabel them. They're things that vary. In general, though, constants and variables, we're going to call these terms, and they are anything that represents an object. Next up, we have predicates. And so predicates are basically, if we have taken like Comp 1001, you can think of a predicate as something that takes in some number of arguments and then returns true or false. And so that's essentially what it's going to do here, is a predicate is going to take in n objects or terms and then return, and then you can sort of intuitively think of it as returning true or false. But really, generally, we're just going to call this a well-formed formula. So for instance, if x and c3 are a variable and a constant, and p is a binary predicate, meaning it takes in two objects, then so if p is a binary predicate and x is a variable and c3 is a constant, then pxc3 would be an example of a well-formed formula. So, okay, we're slowly beginning to assemble our language here. Next up, we have that if phi and gamma are both well-formed formulas, then all of the following are well-formed formulas. So like, the negation of this is a well-formed formula, because we had that this subpart was a well-formed formula. We can keep going. We can conjoin things, so we could say like and p b c, noting that b is a constant and c are constants, and therefore their collection of things is a constant. And you can go through and you can do all of the normal connectives of propositional logic, basically treating predicates acting on objects as propositional atomic variables. The final kind of thing that we can do here is we can quantify over our variables. So if x is a variable, then you can stick this crazy exists or for all symbol in front of it. And when you do that, it means that you can then, basically, it's just a thing that you can do, and then you'll get another well-formed formula. So, for instance, we could stick a for all x in front of this thing, and this is still a well-formed formula now. And it means something if we actually interpret it, but that's semantics, and we're focusing on syntax right now. And so, in essence, that's our language, is it's any way of combining these rules to create an object. So if you write an arbitrary string down, like, you can start to figure out, can I create this string from these rules? If you can, then it is a well-formed formula, but if you can't, then it's not. And so in particular, this would be an example where you can't, for a multitude of reasons. Exists should always be followed by a variable, not a constant, not a predicate, by a variable. And so that already has broken it. Similarly, we said that p was going to be a binary predicate, but we've now put 3 arguments here. So that's also a problem. In general, you have to follow these rules. Predicates can vary what their, how many arguments they take. How many arguments they take is also sometimes called their arity. So this would be like binary, unary for a single object, or like ternary. And we always have this kind of ary suffix at the end, and so we call this concept overall arity. I think I should stop here before I overload syntax too much, but this is kind of like a quick rundown of syntax.